So welcome to the last part of lecture 4. Now, what we're trying to do is just kind of talk about how you write your proof. And I was using a particular linear algebra example, okay? And I was saying that if U is not a subset of W and W is not a subset of U, and if both are subspaces, then the union is not a subspace. And in the last part, I gave this kind of very messy kind of explanation about why it's true. And really what I'm trying to illustrate here is kind of like the thought process that went behind coming to the proof. Now, this is how you kind of come up with the ideas of the proof, but the real trick now is to take what you've just done here and rewrite it properly. Okay, so I actually have done all the work here. And we'll quickly kind of walk through what I've done and what you should do when you're doing these types of problems. So here I've taken everything that we've done before and I've written a kind of a polished proof for the statement. Okay, and it captures all the pieces that we had that we needed. All right, so we have that since U is not properly contained in W, and since W is not properly contained in U, there is a little u in the set difference, U minus W, and a little w in the set difference, W minus U. Okay, and so that's understood to mean that U is in U but not W, and W is in W but not U. Well, then, because each of these guys are in the, or what we're claiming is then that each of these guys is in the union, but their sum is not in the union. And to see why, if this was in the union, then U plus W has to be either in the U or the W. This is just a property of the sets, right? When you're in the union, you have to be either in one or the other or both, right? So if you're in the U, well then since U is also, little u is also in U, we have that U plus W plus the inverse of U, because these guys are both inside of U and it's closed under addition, would give us W is in U. But this is false, right? Because that contradicts this fact right there. And then the same argument applies if we were to kind of just show, so this is false. So maybe I forgot a word here. So this shows that U plus W is not in U. And then the same argument, right, shows that U plus W is not in W. You just kind of switch the order around, right? So here you would have W and then you would have a U over here. And so since U union, oops, let me write this cleanly. Since U union W is not closed under addition, it is not a subspace. Okay, so there we go. We have a nice polished proof. And what this polished proof is doing is it's taking all of this kind of scrap work and putting it in a nice form. And the one thing couple things you might want to notice is that there's some things that we had over here, right, that never even showed up in our written proof, right? So we talked about these things, but they don't actually show up in our argument. And that's when you come to write your proof, anything that you never use it should just be discarded. It should never show up in your final proof. Okay. Now, a couple other things that you want to notice here is I've done some special things, which is use complete English sentences. Okay, so you want to write out everything formally, just like in your textbook. Okay, just you want to write out everything completely. And I have some more tips on my web page. Okay, so see handout on the class web page for more proofwriting tips. Okay, so one of the things that you should never do is you should never say start a sentence with a mathematical symbol. You should actually use proper English words when you're starting your sentences. So use complete English sentences, use proper English grammar when you're writing out your sentences. Okay, so you're aiming for something that looks like this versus something that looks like this. Okay. There's a couple other, one other way that you can sometimes prove stuff is using what's called the contrapositive. And if you saw math one, if you took math 1C, you probably saw this, that the statement is if P, then Q is equivalent to if not Q, then not P. And these two statements are logically equivalent. And because they're logically equivalent, you could either prove this statement or you could prove the second statement. So in our case, another statement, instead of proving the statement that I gave you, you could have proved the following, which is if U union W is a subspace, then U is contained in W or W is contained inside of U. So this is the opposite of the hypothesis, right? So this, before we had Q was not a subspace, so not Q is that it is a subspace. P was that U is not contained in W and W is not contained in U, and that would be the negation of that statement. So I know there's a lot here about going to write proofs. I suggest that you look at my tips for writing proofs, which is on the will be a part of the class webpage, and you'll learn through practice, and we'll try to give you as much feedback when you're submitting your assignments as possible. Okay, so key ideas from today's lecture. Well, first of all, we learned about direct sums. That's kind of like the new linear algebra thing that we learned. We learned how to check if you have a direct sum by checking the zero element. And finally, we learned about proofwriting. Okay, we learned a couple things about proofwriting. So we'll stop there, and I'll see you in lecture 5.